Hello students, from previous video we have this formula of magnetic field due to straight wire carrying current. So what is the formula? B is equal to mu 0 I by 4 pi y sine theta 1 plus sine theta 2. Now what is theta 1, what is theta 2 here? So I'd like you to recall the formula and the figure as well. So the situation was that if this is the straight wire, say with ends A and B, and if we are asked to find out magnetic field at say point P, then we consider this distance to be y, say point O, and we consider that B end is subtending angle theta 2 at point P and A end is subtending theta 1 at uh, point P. Okay. And in case if you have angle subtended at a point say alpha 1 and angle at B say alpha 2, in that case the formula is this mu 0 I by 4 pi y cos alpha 2 plus cos alpha 1. So with this formula in mind, today we will talk about special cases. Now, which are the special cases? So, here are the special cases. First, we will talk about the magnetic field due to wire of infinite length. Then we will see that what if the point is on perpendicular bisector of the wire. And then we'll consider semi-infinite wire. What is semi-infinite wire? That also we'll see today. And then, uh, okay, perpendicular bisector is here. We'll see if the point P is at one of the ends, near one of the ends of wire. So these four are the special cases we will discuss today. Let us start. So now, what if the wire is of infinite length? So when you increase the length of the wire, what happens? The theta 1, theta 2 value increases, and how it affects? So consider that my wire is say of this length and point P is here, and where is theta? So say this is theta 2. Okay. Now what if I consider wire of slightly bigger length? Look at the theta now. Theta is more, isn't it? And what if still you increase the length and again consider point P? So what is happening to theta now? So theta is increasing. Similarly, if I consider the wire to be of infinite length, what will happen to the theta? So in that case, consider that wire is of infinite length. In that case, from point P, if I look at the angle, theta 1 will go something like this. So I have to consider theta 1 to be pi by 2, 90 degree, and similarly theta 2 will also be 90 degree. Okay, so in our formula, what is our formula? Formula is B is equal to mu 0 I by 4 pi y sine theta 1 plus sine theta 2. And what if I consider theta 1 and theta 2 to be 90-90? I'll have mu 0 I by 4 pi y sine 90 degree plus sine of 90 degree. Sine of 90 degree is 1, so I have 1 plus 1, that is 2, and I have 4 here. So ultimately what I'll get? Mu 0 I by 2 pi y. This is the expression for magnetic field due to wire of infinite length. Look at this. So when you have infinite length, at that time sine theta will be 1. Sine theta 1 will be 1, sine theta 2 will also be 1, and hence you will have 1 plus 1 in this bracket, and this is what we get. Okay, so this is the expression for magnetic field at given point due to wire of infinite length. Let us go to next one. What is the next one? at perpendicular distance y from one end of the wire. What does it mean? So when I consider that point P is here. So now this is the theta 2 and here is my theta 1, isn't it? But what if I shift point P slightly close to one end? So now look at the effect on theta 1. Theta 1 is growing smaller, theta 2 is increasing, isn't it? And what if I consider the point exactly here? Where is theta 1 now? So in this case, theta 1 becomes 0. Okay, and I can regard theta 2 as theta. So this is my theta 2, or else you may simply denote it as theta. So for this case, if I consider magnetic field, say mu 0 I by 4 pi y sine theta 1 plus sine theta 2, I don't have theta 1. Theta 1 is 0. And what is sine 0? Sine 0 is 0. And then the formula is mu 0 I by 4 pi y 0 plus sine theta. Instead of theta, now you can write theta. Instead of theta 2, now you can write simply theta, because you don't have two angles, you have just one. And then this is the formula, mu 0 I by 4 pi y sine of theta. Okay, so this is the formula. Of course, see, here is the formula. Of course, you can replace this theta later on by geometry of the figure. Look at the figure. So this is y, okay, and if length is known L, you can always establish the relation between R, L, and y. Okay, so you can always replace this sine theta with opposite by hypotenuse. So if length and y are given, you can find out sine theta. Let us move to next case. What is the third case? Third is find out magnetic field at perpendicular distance y from one end of semi-infinite wire. What is semi-infinite wire? Semi-infinite wire is a wire where you have one end visible or available, but you don't have other end. So in this case, again let us start with the thing which we know. Say this is point P. Say this is theta 1 angle and this is theta 2 angle, and now I am shifting point P here. So what is theta 1? Now theta 1 is 0. Okay, and if I consider the other end to be at infinity, where theta 2 will go? Theta 2 will become 90 degree. Okay, so this is semi-infinite wire where you have one end but you don't have other end. Other end is at infinity. We don't say there is no other end, we say other end is at infinity. And then what is the formula? So now if I look at the formula, mu 0 I by 4 pi y sine theta 1 plus sine theta 2. What is theta 1? 0. What is theta 2? 90. What is sine 0? It is 0. And what is sine 90? It is 1. And then B becomes mu 0 I by 4 pi y sine 0 plus sine 90. Okay, sine 0 is 0 plus sine 90 is 1. So ultimately mu 0 I by 4 pi y. This is the formula. Okay, 0 plus 1, and this is the formula. Now look at this. This is the formula. This is the formula for semi-infinite wire. Means you have one end but other end is at infinity, where you have 4 pi y in denominator. Whereas in case of infinite wire where both ends are at infinity, in that case what is the formula? Formula is mu 0 I by 2 pi y. Okay, so you may notice that difference and keep that difference in mind. With that, let us go to fourth one. What is the fourth special case? At some point on perpendicular bisector of the wire. So now where is the point? So now we have a wire and say point P is here in such a way that angle theta 1 and angle theta 2 both are same. Okay, so theta 1 and theta 2 both are same. We may label them as theta. And then B is equal to mu 0 I by 4 pi y if I write with sine theta 1 plus sine theta 2 in bracket. Now I don't need to write theta 1, theta 2, and then it is simply sine theta plus sine theta, that is 2 sine theta, and then B is mu 0 I by 4 pi y with 2 sine theta, that is B is equal to mu 0 I upon 2 pi y with sine theta. This is the expression when the point of interest is on perpendicular bisector of the wire. Okay, so this is the last special case for today, and that was the topic. I hope you could understand. Thank you.